Okay, we're still on our last bit of video power here. So let's see if we can fit this one in. Okay, so we're at part 284C3M1b7C8E13C9C6D3p34b. Line 22f1fa19C3M1b7C8E13C9C6D3p34 Constituent Avogadro Boltzmann vapor 5G Wow Seti. So this is the alien radio signal, and this is constituent particle, Boltzmann constant, Avogadro constant, water vapor, long distance communication, deep space device from well data is what we're covering in this particular video. So January 26, 2013 was the day we started on it, and February the 4th is today. Keyword is bet, Brunauer-Emmett-Teller to keyword Arrhenius law from the previous video, line 22f1fa19c3m1b7c8e 13c9c6d3p33, Brunauer-Emmett-Teller, Raney, nickel, metals, 5G Wow Seti, and also line 22f1fa19c3m1b7c8e 13c9c6d3p34a, Arrhenius, Brunauer-Emmett-Teller, iron, 5G Wow Seti. And we changed this video, we took out the word iron and we put the word formula instead. And let's just change that right now. Yeah, that's number 34A. That's what I changed that. Okay, so January 31st, the keywords Arrhenius equation to Boltzmann constant in previous video. Line 22f1fa19c3m1b7c8e 13c9c6d3p34a. Arrhenius, Brunauer-Emmett-Teller. Oh, we just did that. 34A. I don't know what I'm doing this again. So the keyword is... I'm repeating myself again. Hold your brain ain't working this week, I'll tell you. Keyword constituent particle. Quote from Wiki. The Boltzmann constant, K, or K with a small b, is a physical constant relating energy at the individual particle level with temperature. It is a gas constant, R divided by the Avogadro constant, and with a little a. So there's K equals R over NA. It has the same dimension, energy divided by temperature, as entropy. The keyword Avogadro constant, quote from Wiki. In chemistry and physics, the Avogadro constant, symbols L and Na, is defined as the number of constituent particles, usually atoms or molecules, in 1 mole of a given substance. It has dimensions of reciprocal mole, and its value is equal to 6.02214129 brackets 27 times 10 to the power 23 mole, and then to the power of -1. Changes in the SI units are proposed that will change the constant to exactly 6.02214 times x times 10 to the power 23 when it is expressed in the unit mole -1. See new SI definitions. Previous definitions of chemical quantity involved Avogadro's number, a historical term closely related to Avogadro constant. Guess who's back? Revision in the base set of units of the internal system of units. My little birdies. Oh, he's back with a friend. And now they're both chattering. And the other one's noisier than the other one. Okay. International... I can just imagine what it's going to be like here in the spring. We usually have about 100 birds sitting out there. And they just... Oh, they all chitter-chatter. And it's fun while you're walking, but when you're trying to film, it's annoying. Revisions in the base set of units of the International System of Units, SI, necessitated redefinitions of the concepts of chemical quantity. Avogadro's number was defined by Perrin as the number of molecules in 1 gram molecule of hydrogen. It was later redefined as the number of atoms in 12G of the isotope carbon-12. Thus, Avogadro's number is a dimensionless quantity and has the numerical value of the Avogadro constant given in base units. The formula from the data is Avogadro constant number, constituent particles, atoms, and molecules. Constituent particles, I'm going to Google it, quote Wiki. The particle number is a fundamental parameter in thermodynamics, which is conjugate to the chemical potential. A constituent particle is one that cannot be broken into smaller pieces at the scale of energy, kT, involved in the process, where K is... Now the dogs are joining in. I can't win. I live in a zoo. where K is the Boltzmann constant and T is the temperature. For example, for a thermodynamic system consisting of a piston containing water vapor, the particle number is the number of water molecules in the system. The meaning of the constituent particle and thereby a particle is thus temperature dependent. And unfortunately, I forgot to put what the next keyword is. Hold on. The next keyword is going to be constituent particle. That's why. Okay, so I'm just going to copy this and pop it back over here. So I guess it's going to continue. Okay, thanks for watching.